Hi, and welcome to Homework 4 for Statistical Inference. Let's get right into it. The data set we're going to look at first is this empty cars data set, and we're going to be looking at miles per gallon. Now, in this example, we want to test a one-sided hypothesis test, mu equal to mu naught versus mu less than mu naught. And the question asks you, what is the smallest value of mu naught that you would reject for? And I think what makes this question hard is kind of the conceptual part of the question. The actual implementation is sort of easy. So why don't we just go through the conceptual part, and then I'll leave the implementation part to you, because the conceptual part is a little different. So let's just remember, we want to test h naught mu equal to mu naught versus ha mu less than mu naught. Okay, and we're going to reject if x bar minus mu naught is less than s over square root n is less than or equal to z sub alpha, where z sub alpha is the alpha quantile of the standard normal distribution, because the problem told us we're doing a z-test. So we want 5% or below there. So z sub alpha works out there to be negative 1.645. Remember, it's negative because 0 is here, and positive 1.645 is that point up there, so that 5% lies above it. Okay, so if we want the boundary where we switch from being significant to non-significant, we're going to want to replace that inequality with an equality and solve. So we get x bar is minus mu naught, and let's just go one step further. We multiply through by s over square root n, z sub alpha s over square root n, and then let's just solve that, and we get mu naught, and then is equal to x bar minus z sub alpha times s over square root n. And I think here's the part that kind of has a tendency to trip people up. We're going to plug in negative 1.645 into here, but it's a negative of a negative, so we're going to get x bar plus 1.645 s over square root n. Okay, and then let's go back to the problem, and I'm just going to show you the answer here. And basically what you need to do is plug in the numbers, the mean, the standard deviation, 1.645. You can just plug in, or you can actually grab a much larger decimal expansion of the quantile by using Q norm 0.05, but that's usually unnecessary. And the only confusion here, I think, is messing up the signs, and it's very easy to lose track of your bookkeeping.